Well, good morning, good afternoon, everybody. Welcome in from across the continent to all like 500 of you from pretty much every state and province I can shake a stick at. If this is your first exploring by the seat of your pants, which it is for so many of you today, we are all about bringing conservation, adventure, and science into classrooms around the world. And everything we do goes to our YouTube channel. So you can check out this program in 3 weeks, 3 years. You can check out 4,000 other programs on any topic you are keen on. There is so much to explore and discover right there. Now, of all the days you could be joining us, whether you're new or whether you've been here a bazillion times, today is particularly special because today marks my favorite month every school year. So we do big space month, we do a big ocean month, we do all sorts of cool themes throughout the year. But in February, we kick out all the dudes, everyone except Joe and I as hosts, and spend the entire month solely showcasing and celebrating the most amazing women in science on planet Earth. We've got like 45 plus broadcasts this month on every topic imaginable. I was just saying to our live classes, we've got lamprey biting people, we've got cool earthquake geologists, mega quakes coming up, we've got James Webb Space Telescope, shark people, and more. It's going to be an absolutely wild ride. I also just want to encourage all our classes. We're not actually even partnering with them, but If Then She Can is the greatest resource hub for amazing women in STEM ever. I can't encourage you to check it out enough. There's so many things there to explore. It really does truly rock. Now, of all the people that we wanted to bring on to help start our month in style, we had to welcome back the person who's come on more than any space person ever, I think by a good margin, and certainly one of my favorite scientists personally in our history, and that is Dr. Abigail Fraeman. So she is a Mars research scientist. She gets to think about other worlds for a living. And if there's a better job than that, I do not know what it is. I'm going to bring her on in just a second. Forgot a quick housekeeping note. We do have a Kahoot today. So between our talk and Q&A, if you want to play along with a little quiz, you can pull up that game pin and do just that extra way to keep it interactive and fun. But without further ado, you're not here for me. Abby, welcome back to the broadcast for the 8 bazillionth time. And thank you so much, and take us away to tell us all about Mars.
Oh, fabulous. Thank you so much for having me. I always love coming to speak to all of these classrooms across North America, and let's just get into it. I'll go ahead and bring my slides up here. Can I just get a check that you can see?
Perfect. Couldn't be better.
Fantastic. Well, hello, everybody. I am thrilled to be talking to you today about what I get to do as an explorer, exploring Mars with the Curiosity Mars rover. I'm talking to you right now from my office, which is at NASA's Jet Propulsion Laboratory. We're located in Pasadena, California, which is on the west coast of the United States, just outside of Los Angeles. When you hear the phrase NASA, it's a little confusing. There's not actually just one place that is NASA. It's actually a whole bunch of facilities that are spread all across the United States. Each facility has a little bit of a different specialty. For example, the Johnson Space Center in Houston, Texas, specialize in the astronauts. They're the ones who control the International Space Station and do the astronaut training. The Kennedy Space Center in Florida is where all of the launches happen. Here at the Jet Propulsion Laboratory, our specialty is anything to do with no humans. So we specialize in robotic exploration. We send things to explore places that humans can't go. One of these places, at least for now, and the place that I'm very excited about exploring is Mars, the red planet. So I like to think of Mars as my other office. Mars is the 4th planet from the sun, just one over from Earth, our 3rd planet from the sun, a little bit further away, a little bit colder, a little bit smaller, a little bit thinner atmosphere, but still some fascinating things to look at and some fascinating histories. Of course, I got to show you, I showed you earlier, if you dialed in early, the beautiful view out my window here of the mountains in the background. But on Mars, here's the view out my window right now. This is what I was looking at yesterday morning when I helped to operate the Curiosity rover. This is what we saw when we came in the morning, and we looked at this image and had to figure out what the rover was going to do that day. Where did we want to drive? What rocks did we want to analyze with the instrument's arm? This is a very cool terrain that we're exploring right now with these kind of ridges and hollows. And there's some really interesting history that happened to make it look so strange, this kind of bumpy terrain. But I'll get into that in a little bit. Before I talk about exactly what Curiosity is doing, I like to step back and talk about why we're exploring Mars at all in the first place. And for me, there's 2 really big reasons that I think this is such a cool place to get to know. First, Mars might hold the key to answering the question, are we alone? Which I think is one of the biggest questions we can ask as humans. Right now, the only place in the entire galaxy that we know Earth exists is our own planet, Earth. But we are finding in our solar system thousands and thousands of other planets. And so there's a big question about whether any of those planets might also have life. One of the best and the easiest places to look at this question is actually Mars, our next door neighbor. Today, we know Mars is very, very cold, very, very dry. The atmosphere is very, very thin. In fact, it's so thin that it doesn't really protect the surface from all of this dangerous radiation in space. So the surface just basked in what's called UV radiation. It'd be like if you went outside on a really sunny day and got a really bad sunburn. That would be like on the surface of Mars. But we think like 3.5, 4 billion years ago, Mars was a very different place. We think it was a much thicker atmosphere. It was a lot warmer. It was a lot wetter. And we think that all of the things that were present on Earth when life arose on Earth could also have been present on Mars. And so this is the big question. If all the ingredients for life were there, did it arise on Mars billions of years ago? If we find the answer to that question is yet, that has really important implications about the prevalence of life and how common it might be in the entire solar system, galaxy, universe. Another reason I think Mars is so exciting to study is this idea that one day us as humans will be able to go there, to be able to continue our scientific exploration to understanding what Mars can tell us about life, about how planets form and evolve. And before we can do that, we need to understand the kind of things that these humans will face. What are the dangers that they might find? I talked about the radiation on the surface being very strong. What are the temperatures they might experience? What are the kind of weather that the humans might encounter? We know Mars has these big dust storms that can be so big they take over the entire planet. Is that something we're going to have to deal with? We also need to study Mars to understand if there's anything there that we can use to live off the land. Where can we find frozen water on Mars that maybe humans could one day use, or water locked in the rocks? These are all the kinds of questions that we're trying to answer now to set us up to eventually one day be able to go to Mars to explore. Some of the ways that we study Mars is through the field of geology. And so one of the things I get to do is actually go to a lot of really Mars-like places here on Earth and do geology. I get to look at the rocks, understand their history, how they've been shaped by the environments that they're in, and use what I learned to help better understand what I'm seeing at Mars. So here are some pictures of some of the cool places I've gotten to go. Places usually where you have a lot of volcanic rocks like Hawaii, Iceland. I'm currently working on a project where I'm going out to Southeast Oregon, which is on the west coast of the United States, looking at these big lava flows and desert environments. So it's a lot of fun, even though most of my field site I can't visit in person. Some of them I do. Of course, to look at Mars, we can't go there, bring our rock hammers, break open the rocks, look at what they're telling us. So instead, we've sent a fleet of robots to explore it, both from orbit. You can see all of those pictures orbiting Mars. Those are things that have either been attempted to go to Mars or successfully gotten to Mars and have been able to look down at the planet from above. And then we've also, at this point, landed a couple of things on the surface of Mars, a mix of landers. So these are things that just land on Mars and can make lots of measurements just where they land, or my absolute favorite, rovers, things that can land on Mars, but then have the ability to drive around and move. So if you see a really cool rock off in the distance, you can go there and you can look at that rock and try to understand what it's telling you about what Mars was like billions of years ago, and better get at this question about whether Mars once had life. I like rovers so much, probably in part because it was a rover that inspired me in the first place to study Mars. And that was the Opportunity Mars rover. This was a rover that landed in 2004. And this was the first picture that Opportunity sent back right after landing in Mars. And I thought this picture was the coolest picture I'd ever seen. Before Opportunity, all of the pictures that we'd seen of Martian surface were very rocky and dusty and really rust colored. And this was the first time that we saw a view of Mars that was just this dark sand with these very strange light colored rocks poking out in the distance. And, it's so exciting because Opportunity was a rover. We were actually able to go drive over to those rocks, look at them, discovered that they were laid down in liquid water in a very different environment on Mars billions of years ago. And this was really our first taste that the ingredients that we know life needs, especially liquid water, had once been present on Mars, even though they're not there today. I was really inspired by this picture because, I thought it looked cool. It made Mars look like a place that was worth exploring. But what was really cool was getting to see the geologists on the Opportunity team look at this picture and see even more. They were able to see these light colored rocks and say things like, that's bedrock. That's so important to me as a geologist because this is rock that formed in place. It tells me exactly what the environment was like at this particular spot in the past. They were able to look at the patterns on the rocks and tell that they were laid down in water. They were able to look at the minerals in the rocks and see lots of different salts. And I thought that was just the coolest superhero trick to be able to do that. And that's why I wanted to study geology, to be able to look at images like this and use them as a way to look back in time. I'll give a quick plug. If you want to find out a lot more about Opportunity and her twin sister rover Spirit, there's a fabulous documentary on Amazon Prime called Good Night Oppie, and it tells the whole tale of this mission and the people who built it and what Opportunity discovered. But because I can't talk forever, I'm going to spend the rest of my time talking about the rover mission that I work on now, which is the Curiosity rover. I love this picture. It's our NASA rover family portrait. It shows the evolution of the rovers that NASA has sent to Mars over the last 20, 25 years, starting with the first one, Pathfinder, that little one at the bottom. That was just kind of a proof of concept that we could send rovers to Mars and command them remotely. Then, of course, there was Opportunity and her twin sister Spirit that were the first really scientifically capable rovers we sent to Mars. Opportunity and Spirit found evidence that Mars once had liquid water in the past, at many different times in the past, in many different kind of flavors of water in terms of how salty it was or what its pH was. And Curiosity really builds on the finding and the technologies of these earlier rovers to try to get at even more complicated questions. And in particular, with Curiosity, we're trying to find out whether all of the ingredients that we know life needed would have once been present on Mars. So I've mentioned liquid water. Other things we're looking for with Curiosity include the right elements, all of the building blocks of life, and then also things like organic molecules. These are molecules that have carbon in them that we know for you and me, that's kind of the fundamental things that make up our bodies. And so to try to discover these elements, potential energy sources, and these carbon containing molecules, we needed a really big rover to carry really sophisticated science equipment. We selected a fantastic landing site for Curiosity. We landed in the big crater that's named Gale Crater. But the really exciting thing about this rover was off in the distance, there's this big mountain called Mount Sharp. And the idea was we'd land at the base of this mountain. And when you look closely at the mountain, what you see is lots and lots and lots of layers. And we think each of these layers tells a different point in time of Mars's history. And so we were going to go to the base of these layers and then climb up the layers. And as we climbed higher, we'd be looking at younger and younger rocks. And it would just be like reading chapters of the book of Martian history. kind of, if you think about, like, if you went to, say, the Grand Canyon, and you were to go to the bottom and then hike your way up, you'd be hiking through Earth's history and time. That's exactly what we're doing with Curiosity, climbing this mountain. We could also see, even before we got there, that these layers had different kinds of minerals in them, things like salts and clays and iron oxides, and all of these form in different settings and tell us something really different about what the environment of Mars was like when those minerals formed. And I'll tell you, many, many years later, we're all the way kind of way in the back now. We've climbed up almost a kilometer up this mountain. So we have seen many of these layers, and we've learned a lot about the storybook of Mars's history. But getting back to the instruments on Curiosity, this is just an awesome picture of Curiosity looking really cool. This is really highlighting some of the science instruments that we have on Curiosity. I think the biggest one you'll notice is this laser on top of the rover's head. We can actually use this laser to shoot at rocks up to 4 meters away and vaporize them. And we can tell the different elements that are in the rocks looking at the kinds of vapors that come off. We also have a drill on the end of the rover's arm that we use to drill into the rocks to make these powders, which we then deliver to one of 2 laboratory instruments that are actually inside of Curiosity. So I like to show this. Curiosity is actually kind of like a mobile chemist. So you can imagine wearing a lab coat and goggles, but there's these 2 instruments that are inside the rover that look at these drilled powders that really get at looking for these ingredients for life, these carbon-containing molecules, these very special kinds of elements. And so they tell us a lot of really detailed information about the rocks. I did mention that I had a special shout out to Canada, and I have to point out that one of the instruments that's on the end of Curiosity's arm, not the drill, but a different one called the Alpha Particle X-ray Spectrometer, or we like to say APXS, that was actually built and is operated by a team in Canada. So there's a very important Canadian component who are part of our science team. We use this instrument also to get at information about what the rocks are made of. We use it almost every day on Mars. It's a really important instrument. So just want to make sure to highlight that this really is a global international rover. We also have instruments from Europe, places like France and Spain have contributed instruments as well. This is just a family portrait of some of the drills that Curiosity has collected, drilling into the rocks, collecting that powder to analyze it. I love this picture because it shows just how diverse Mars is. We usually think of Mars as the red planet, but that's because all of this rusted dust that covers the surface, that's what makes everything red. It turns out when you actually brush below the surface and you can look into the rocks themselves, Mars is not completely red. Some of Mars is red, but some of it's kind of purple, green, gray, brown. And all of these different colors of Mars are reflective of the different minerals that make up the rocks, which are different because these rocks have a different history. And they're telling us about how Mars's climate changed and how it went from this place that might have been good for life to the really dry, inhospitable place that it is today. This is an orbital view of Curiosity's journey. We landed right where the circle is in an area we named Bradbury Landing, and then we drove to our first site that we called Yellowknife Bay after the location, also up in Canada, where there's some very old rocks that are maybe comparable in age to the rocks we're looking up at Mars. But in the Martian Yellowknife Bay, one of the first things that we found was already evidence for all of the ingredients of life. It turns out the rocks that we saw here were laid down in an ancient lake. We could tell based on the minerals that were here, things like clay minerals, that the water in this lake would have been fresh water, would have been something that you or I would have loved to have had a nice cool drink from. And then we could also see that trapped within these clay minerals that formed in this lake were organic molecules, these carbon-containing molecules that are the building blocks of life. And we could see that they're not only just kind of simple molecules, but they started to get a little bit complex, which is getting closer and closer to what you would expect for life. So this was an amazing, awesome finding. Kind of like as soon as we landed, we were able to say, yes, we can now definitively say that Mars had all of the ingredients life needed. Now we just have to answer the question of whether there was life on Mars. It's kind of like if you were baking cookies, we've landed, we found the butter and the sugar and the milk and the eggs. And so the question is, were they ever combined and baked in the oven and delicious cookies formed, but in the form of life? We're still trying to figure that out. But that was like, what was that? 13 years ago. What have we been doing since that time? Well, we have continued to climb this mountain, and I'll just highlight some of my favorite things that we've seen along this wonderful journey, looking at this really diverse place. And in particular, all the way up here, about halfway up the mountain, we encountered a really interesting change in the rocks. We saw evidence that the rocks where we landed were deposited in a lake. And it turns out a lot of the lower part of this mountain was also deposited in a lake, which was cool. It tells us there were lakes on Mars, and it tells us these lakes probably lasted for tens of millions of years to have built up a mountain that is as tall as the one we're climbing. But when we reached this particular height in the mountain, we saw that the rocks changed. They went from sort of these light-toned lake deposit rocks to these darker colored, much steeper rocks that were eroding in a very different way. And we were able to drive up amongst the rocks. This is a really dramatic area we explored. We called Paraitapui Pass. And by looking at the layers in the rocks, what we could tell is that these were no longer rocks that formed in lakes, but instead, these were rocks that formed in much drier environments where you had lots of wind-blown sand. So either kind of sand sheets with ripples or big sand dunes blowing across the environment, that eventually the sand grains that made up these features would have just gotten a little bit cemented and then turned into rock in a process we call lithification. And so what these are that we're looking at are lots and lots of fossilized sand dunes. Here's another example of just one of these incredible buttes that we can look at, and we can look at the geometry and the kinds of the layers that are here to tell us how they formed. So this was telling us about the drying out of Mars, the change from the lakes to the sandy environments. We also got to see some cool chemistry. This is an example of what we saw at the feet of the rover in this area. You can see these kind of big golf ball sized features. It was fun. We drove over them. We crushed them open with our 1-ton rover. And then we were actually able to look at what these little golf balls were made of with the alpha particle X-ray spectrometer and the laser. And what we found was that there was a lot of salts in here. So this again is telling us that this is a salty, a dry environment, but not completely. The higher we climbed, the more unusual things we found. Eventually, we found this very strange layer we called the marker band that had these really interesting textures in it. Here's what it looks like from above. And it turns out that these are textures that geologists call wave ripples, and they're textures that form when you have a very shallow body of water that's getting blown across the surface, sloshing back and forth. So even though Mars dried up, it wasn't completely dry all the time. Eventually you had the water come back. And so it's this kind of cyclical changing environment on Mars. Here's just a pretty picture looking up the mountain. This is a big channel that we got to climb through. This is so cool. Like, these are rocks on another planet. Isn't it incredible to get to see a view like this? As we climbed, we also explored an area called the Geddes Vallis Channel, where we found some really unusual surprises. If you look here, we kind of pulled into this channel, and all of a sudden we saw the rocks at our feet were white colored. What? This is what a close-up view of that rock looks like. Totally weird. I've been working on rovers for 20 years now, and I've never seen a rock that looks like this. We like to crush things open with the rover wheels. So that's what we did. We crushed this rock open. On the inside, you can see it's kind of this greenish yellowy color. And when we took a close look at it, we found this was actually a rock that was made of pure sulfur, which was something we had never discovered before ever on Mars. We're still trying to figure out what it means. We don't really know how this sulfur formed. It's puzzling. We have some maybe ideas, but it's showing us that even though we've seen so much of Mars, there's so much more to see and so much more to discover. This is just a nice little movie that kind of shows us as we sat in one place. I love this. It's just a day on Mars. You can see the rover's shadow moving across the surface. Pictures like this make me really appreciate that Mars is a place and it's a planet. I think it's so cool. And then where we are today is exploring this area called the boxwork, where we see this series of fractures and hollows. We're still trying to figure out how they formed. We think it involves groundwater that was flowing through Mars long after it dried up. And so it's been a lot of fun looking at the differences in the textures and the composition of these fractures and ridges and hollows. And in fact, this is what we did this weekend. We drilled into one of these ridge tops. You can actually see there's 2 drill holes. We had drilled it right before Christmas. And then what we saw was so cool, we decided to drill it again. And what we are doing right now as we speak on Mars is analyzing the powder from this drilled sample to look for more evidence of these organic molecules. We're actually mixing it with this special cup of chemicals that we brought on board. We only brought 2 cups, and we're using the second of these 2 cups to mix this powder with that to try to see how we can find out what's inside of it and even better identify the kind of compounds that are in this rock and what it might tell us about the history of Mars and life. So I'll leave you with just 3 more pictures. First, this shows an image of where we're going. I think there's still so much of this mountain to explore. We can see the rocks in the distance look totally different. In this image, you can see in the front, dark Martian sand. On Mars, the sand is black because it's made of crushed up volcanic rock. And so that's what you're seeing, this black Martian sand. And then even further away, it's a unit we call the Yardang unit. A Yardang is a geologic term to describe rocks that have been shaped by the wind, kind of in a shape that looks like what you'd get on a ship, where you get kind of a pointy, curvy shape. And that's what those features are way off in the distance. And we think those rocks are even more different from anything we've seen. So I can't wait till we get there and find out what they're made of. I'll also just give a shout out. One of the things we've been doing with Curiosity is also looking at the Martian environment. So the entire time we've been on the surface of Mars, we've also been measuring the temperature, the pressure, the radiation that we've been receiving. And so now we have a years-long record of all of this that helps us, again, better understand the environment. And this is part of the preparation to send humans to Mars. This is a gorgeous picture that we took during a very specific time of the year when we have clouds that come out right as the sun set. This only happens for a couple weeks out of the Martian year that we discovered. And there are these beautiful kind of pearly clouds lit by the setting sun. And in this particular thing, we get these rays they call crepuscular rays. Sometimes they're called God rays. You can see them on Earth on cloudy days sometimes. And this is the first time we can see them on Mars too. I thought it was so cool. But I'll just end with one of our final postcards and our kind of mantra here at JPL, which is to dare mighty things. It takes a lot of work to explore Mars with rovers, to build them, to operate them, to understand what they're showing us. But I think it's work worth doing. And I'm looking forward to the future for what we're going to be able to continue to discover, and what we'll explore next. So thank you so much for your attention, and happy to turn it over to Kahoot and questions.
Thank you so much, Abby. You are just so, like, you're dripping with enthusiasm about this, and that always shines through. It's such a thrill to have you on because, I mean, we've got robots with lasers on another planet, and if there's a cooler thing than that, I don't know what it is. So thank you very, very much. If you want to exit screen share, come back to us, have a bit of a conversation. Awesome. For those who are new to Kahoot, I know many of you are new today. The faster you answer, the more points you get, and what you win is Abby and I's everlasting respect. So we're going to dive in with this in a second. If you don't have Kahoot, that's totally fine. You can just yell out the answers in your class. It's just fun to play along. And then we are going to head to Mr. Alston, our Rochester crew, and Mrs. Boulos' class in order. We're coming to everyone, I promise. Big, long Q&A. And if you have extra questions, you can email them to us at Exploring by the Seat of Your Pants. We will take as many as we can over the next 15, 20 minutes. But here we go. In 3, and Abby, if you want to help us with hints, please do. 2, 1, here we go. Humans have been to Mars how many times? What do we think? There's that picture from earlier in the presentation. Have we been once? Have we been 5 times? Have we been 50 times? Or we've never been? We're going back to the moon soon to circle around it with the Artemis 2 mission. That's going to be coming up in the next month and a bit. Fingers crossed all goes super well with that. How many times have we been to Mars? This is actually something that we get a lot. So yeah, we had a lot of people thinking we've been quite a bit. We have never been to Mars. That is the correct answer. We are a ways away from maybe having the technology and sort of skills to do that in quite the way that we'd want to, but it's a very exciting prospect for the future. And as Abby said, we will go to Mars. Like, we have planned this. We have talked about this for a long time. And it's exciting that you kids are coming up in the golden age of space exploration. Like, it's the best time to be keen on space ever. All right. It only takes a few days to get to the moon. We blast off, we get there in a few days, like a nice little vacation. How long does it take to reach Mars? A few days? One week, 1 month, or many months? Abby, do you have a hint for us?
Well, Mars is really, really, really far away.
Really far away.
Really far away.
Yes, many months. So correct me if I'm wrong. 5 to 8 months is what jumps into my mind when I think about Mars. Am I correct in that? Or
yeah, that's a family, 6 to 9.
Okay.
Depending on where the planets are orbiting. But yeah, many months.
All right. Amusing hyena keeps our lead over imaginative magpie. Here we go into question 3. Mars is what temperature compared to the Earth? I really like this question. Is it much hotter, much colder, or about the same? What do we think? I think, I don't know. Give us a hint. Sorry.
Usually there's one answer, especially at night.
Yes.
So it could be a bit of a trick question.
Yeah.
Sometimes in the summer in Mars, it's a little bit closer to Earth in like the deep winter of Canada or the northern US, but yes.
Look at this mix though. So, Mars being red, I think works against it in people's understanding of it. It is further from the sun, so it is colder most of the time. It does not have the atmosphere to trap in the heat that we do. There are occasions where parts of Mars can be warmer than parts of Earth, but by and large, it is much colder than our planet. Let's see what that does to our leaderboard. I'm using hyena almost wire to wire with a magpie right behind. Okay, final question, and then we're going to our Cougar Cubs, Mr. Alston's class. Why do we send robots to Mars? They don't need food to survive. They can survive tougher landings than people. They can do things people can't. Or, hint, hint, nudge, nudge, and perhaps what I do in every coot, all of the above. This is just to reinforce that, like, human astronauts going somewhere is really, really exciting. Don't get me wrong. But robots have done most of the exploration in our solar system, and it's really important that we fund and support those missions because they have given us most of the big discoveries. Our audience killed it with that. Let's see what that does to our leaderboard. All right. Cute Goose is third. Second, just barely. I'm using hyena. Oh, taking over the end. Does magpie win? Let's see. Imaginative magpie. If you are them. Oh, our Colin homeschooler. Way to go. Way to go, man. You got the suit. You got everything. You're amazing. Mr. Alston's class, we're going to head to you guys. Grade 4. If you want to come in and unmute your mic, you can kick us off with our first question. And YouTubers, please do share in the chat as well. Hey, grade 4s, welcome in. Oh, come on up. Ask away.
What holds the dust?
What holds the dust?
Yeah.
Oh, in the drill.
Yeah.
Yeah. So let's see. The drill on Curiosity is actually just very similar to the kind of drill you might buy from the hardware store. In fact, the drill bit on Curiosity is something that's modified from what we got at the hardware store, which I think is so cool. But what happens is there's like a sleeve around the drill stem. So as we drill into the rock, the powder that we make goes up around the drill stem and it gets trapped in the sleeve. And then behind it, there's actually this whole kind of contraption that as the powder goes up, it can go into this kind of box-like thing that can then hold it. Now, this is a fun question and fun information about operating rovers on Mars. When we first designed it, once the sample kind of went up into this little box, we had like sieves and we could shake it all around. And then we would do this very intense way to transfer it. But at some point, part of the drill stopped working the way it was designed. So the way we use it now is we just drill into the rock like you would use a drill on Earth. And then we move the drill bit and we hover it over where we need to put it into the instruments and we just spin it in reverse. And a little bit of that powder drops out into the instruments. It's a wonderful way to show how engineers tackle problems that we have on another planet. When you can't go fix things, just figure out another way to do things.
Yeah, super cool. Great first question. Thanks. I mean, that was awesome. All right, Mrs. Struckman's class, our Rochester crew, come on in and take us away. Hey, guys. Hi.
Hey, we gotta.
Yeah.
How did you invent the lasers?
Ooh.
Ooh, good question. So I didn't actually invent the laser, but some very smart scientists and engineers did. It's based on a thing that we use here on Earth all the time to analyze rocks called laser-induced breakdown spectroscopy, which is quite a long name. We also call it LIBS. But someone, I don't know when, invented this technique a long time ago. And so what we did in the last 20 years was actually figure out how to take it and make it small enough and ruggedized enough that we could send it to another planet.
Super cool. Ruggedized is my favorite new science term. Thank you very much for that in my day. Because they're on lunch, I'm going to skip ahead and change the order a little bit. Our FLCS 6M crew, if you want to unmute your mic, come on in and share with us, and then Mrs. Boulos will come to you next in a second. Hey.
Hi.
Hi.
Our question is when the rover breaks down, what happens next?
Yeah.
Does it just become junk on Mars, or can it contaminate in this process?
Yeah, great question. When a rover breaks, we try to fix it. We do the best we can. Like I talked about with the drill, if there's a way we can work around something that breaks, we'll do it. The Opportunity rover, one of the wheels broke, but we kept driving it, just kind of dragging the wheel along. But eventually, when the rover breaks, which all rovers will, we just leave it there. You know, we haven't gone to Mars yet. If we could bring anything back from Mars, it wouldn't be a broken down rover. It would probably be a bunch of rocks. Yep. So, you know, maybe one day when humans go to Mars, they'll be able to find the rovers, fix them up, or turn them into a museum. But for now, yeah, we're kind of littering the planet. But it's okay.
It's okay because we're getting some really, really cool science out of it. And I think you mentioned a really good point there, is that if we ever do have the potential to even bring back something like that, we'd probably leave it there as sort of an icon of our early days of exploration, like centuries down the road if we go back. But it's a neat way of thinking. Same with our moon robots. Like everything that we put on the moon is still there. We have not gone and taken any of our robots back just yet. So great question, guys. We're going to try and do 2 rounds of these. We're whipping through them, which is awesome. Mrs. Boulos' class, we're coming to you. Cullen next, and then Levi. Come on in. Hey, grade 6s.
So, have you ever helped to build a rover?
Ooh, cool question.
Ooh. So I haven't gotten to help build a rover. I was still a student when Curiosity landed. So I just became involved as we started to operate it. But I am currently helping to build an instrument that we're going to send to the moon, hopefully in a couple of years, that's going to be on an orbiter that's going to look down at the rocks on the moon and tell us more about what they're made of and look for water on the moon. So that's been really fun for me. I'm learning a lot about how hard it is to build something for space and how you have to be super, super careful in everything you do to make sure that things work. We talked about when things break down, there's only limited things you can do since you can't actually go out there. So designing something for space is really different. And so I'm learning a lot about that right now.
The coolest engineering on planet Earth is to design things for space. And we've done a lot of Mars and other space engineering programs as well. So I encourage you to check those out on the YouTube channel. But like, it's just really fantastic stuff. I will say too, I know we've got a huge line of kids in a lot of the classes. Email me extra questions. We're going to take as many as we can over the next few minutes. But our Cullen homeschooler with the coolest suit ever, for those who haven't seen this, welcome in your like full Artemis gear. This is awesome. What's your question for us?
What is the most surprising thing you have learned about Mars?
Ooh, no pressure.
No pressure. I think we've learned so many surprising things. I think what is surprising to me is that the more we explore, the more we find and the more questions we ask. So I showed those white rocks that were made of sulfur. No one expected those to be there. And no one expected us to find anything so new after exploring the surface for 2 decades. So for me, overall, the discovery is that Mars is so diverse. It had a really complicated history. It was once wet, but then it was dry, then wet, then dry. And then the water was different in different places. And you know, all of this, I am using it as a pitch. We got to go to more places on Mars. There's so much more to explore that we haven't seen yet on the surface.
Yeah, thanks for the question. That was awesome. All right, Levi, we're going back to another homeschool group, and then we're going to try and do a whole other second round with everyone if we can whip through it. Welcome in and
Hi, how are you doing today?
Good. How are you?
Awesome. So I was wondering, do you have any idea why there's no water on Mars now?
Good question. So I should be careful when I say there's no water on Mars. There is some water. So there is frozen water that's frozen in the ice caps of Mars and under surface in the poles. There's also gases, water gases in the atmosphere. There's a little bit of water vapor in the atmosphere, but there is not today any liquid water on Mars. And that's because Mars is simultaneously too cold, water would freeze, and the atmosphere is too thin, water would vaporize right away. So the question is, how different was Mars in the past that it was warm enough, the atmosphere was thick enough that it did have liquid water?
Yeah. I know we didn't talk about Venus today, but we think Venus was also kind of like Earth and then did the opposite. Like both Venus and Mars are sort of like test cases for if things went really wrong with our atmosphere on Earth and what that would lead to in completely different ways, which is super cool science. I'm going to stress, just in case any classes have to go to, mars.nasa.gov is like the greatest resource ever. No one does better education than NASA, and you can find out so much there. So go explore. You can check out robots, new pictures, all sorts of cool stuff if you want to follow up after this is done. But we've got time for another round of questions. Mr. Alston's class, come on in grade 4s and take us away. Hey, so many. Awesome.
Have you ever lost a robot in Mars?
Oh, have we lost a robot? No, we do a pretty good job keeping track of where the rovers are. There's sometimes when we lose track of orbiters, we have less of an understanding of where they end up because Mars has a thick enough atmosphere that it can affect the way the orbiters are orbiting. So some of the older orbiters, we don't know where they are so much anymore, but we try to keep pretty close tabs on what we have on the surface.
I love the question. Thanks, guys. All right, Rochester, there's so many of you, like a whole lineup. Hello.
What is your question?
Come on up.
Your turn.
Hi.
How many rovers have been sent on to Mars?
Ooh, cool question.
Good question. How many rovers? Let's see if I can count them. There was the Pathfinder rover, Spirit and Opportunity, Curiosity. After Curiosity, there was Perseverance. And then there's also a rover that China has sent to Mars. So 6 total rovers and then another couple landers.
Very cool. And by the way, you can explore all these. Again, Mars's NASA website. Check out Mars stuff. Like if you want to find out more, there's so much when this broadcast is done that it's just scratching the surface. We're going to do 4 more questions, rapid fire. Mrs. Bullis' class, come on back in, unmute your mic and take us away. Hey, run, sprint.
We didn't know that we're getting a second chance. Here.
Yeah.
No, but,
Got the question.
Have you found any fossils?
ooh, any fossils?
Ooh, no, but we're looking really hard. We haven't found any fossils yet, although our eyes are always peeled. If there are fossils on Mars, it might not be like a dinosaur bone. It might be something a lot smaller, like a fossilized bacteria or microbe. But we're looking for any and everything that we might be able to find.
If we find bacteria or fossils of bacteria on Mars, it'll be the biggest science story in the history of the world. Like it'll be all you hear about from your teachers, parents, everyone forever. It'll be life elsewhere in the universe. We have not found that anywhere yet. It's really, really exciting that we have the prospect. And we did find the coolest thing on Mars we've ever found not too long ago. That's like, we're trying to prove that could have been made by life. It's a really, really cool time for science. So again, follow along with us. Join us for more lots to explore. Great question, guys. The rest of questions with those big classes, email them to us. Please do email us extra questions. I'll get them to Abby, I promise. Cullen, we're heading to you. Hello. There's a cap now.
Do you think there's ever life in space?
Ooh, that's a great question. I think there are too many planets and too many places and too many possibilities for there not to be life elsewhere in space. We haven't found it yet, but I think there's too many chances. It's hard for me to think that we're the only place that has life in the universe.
I want to say for our class's sake, so this is your perspective, we bring on a lot of space people. Every space astronaut, engineer, research scientist, everyone says the same thing. I really encourage you all, check out the James Webb Space Telescope's Ultra Deep Field, the greatest picture in all of science ever taken, like the one that moves me, like it makes me want to cry. Check out that picture, see how many galaxies are in that picture and how small bit of sky that represents and tell me you think that we're the only thing in the universe that has life. It would be shockingly unlikely for that to be the case, which is really, really exciting. Whether we contact it or not, we'll see. We keep exploring, but every person in space ever thinks there's life in the universe, which is very, very cool. FLCS, we're coming to you, and then we'll wrap up with Levi in a second. Come on in. Take us away.
What is the most interesting item you guys have found on Mars so far?
No pressure. Most interesting item ever on Mars.
There's so many cool things. I think to me, one of the coolest things was the rocks that we've examined with Curiosity, those first ones from Yellowknife Bay, and found had not only just carbon-bearing molecules, but really complex chains, long chains of carbon-bearing molecules that might actually be the breakdown products of something called amino acids. That to me is super exciting because that is really the building blocks of life.
Pretty freaking cool. I want to note before we go to our last question again, mars.nasa.gov, I'm going to email all our teachers everything, including a little survey if you get the chance to fill out. But I want to note for our Cullen homeschooler, kids in North Carolina and Arizona are commenting on how cool your costume is. So way to go. It totally rocks. Lavi, come on in and take us away.
Hi. I was also wondering, could you consider making another rover to be a helper if the other rover gets broken?
Absolutely. It might be hard to kind of get in there and fix what's broken depending on what's broken, but we do have robots in space helping fix other robots. Things like on Space Shuttle was fixing the Hubble Space Telescope. That was kind of robots helping to fix robots with some humans involved. Personally, though, if I had a broken rover on Mars, I wouldn't want to send another rover to fix it. I want to send another rover somewhere completely different to do more exploration.
Levi, great last question to wrap us up. I know we could go all day with these, so please do message us with more. Abby, before we wrap up and bring in our classes to say a big thank you and farewell, is there any final message you want to leave us with about Mars and Mars exploration?
Oh, just thank you all so much for your attention and your excellent, excellent questions. Space is awesome. There's so much happening in space right now. We're going to have a launch to the moon soon. There are amazing images coming back from the Webb Space Telescope. So if this is something that's exciting to you, stay curious, stay interested. We're really in the golden age of what we're learning.
No better message than that. I can't encourage you enough. I'm going to share all sorts of cool resources when we're done. Abby, as you know, I'm going to bring in all our classes to say a big thank you and farewell. So Mr. Alston's class, Rochester Secondary, Mrs. Burrows,